Today on Engine Power, we revisit an old classic, the Ford Windsor. And since there's truly no replacement for displacement, we're giving it more power by making it a stroker. And speaking of HP, we're putting our Chevy Big Block through the paces in search of 1,000 horses or more.
Welcome to Engine Power. Today we're dragging one of our engines out of the archive to do a few upgrades. This is our 351 Windsor we used as a comparo engine against an LQ4 LS earlier. Now this is a Powertrain Products short block, so it has good solid internals. It has a set of trick flow heads on it, some decent valve train, and a dual plane intake. Right now the engine is stock-ish in cubic inches. It has been overbored but retains the stock stroke, and we're going to make it into a budget-friendly stroker engine. But before we do that, we are going to carefully tear the engine apart to truly evaluate how it was running. There were several variations on this 5.8-liter engine from the factory, making around 200 horsepower and 310 pound-feet of torque. Reasonable numbers for a stock piece, but we need more power. We started with a Powertrain Products long block that had a 4-inch bore and 3.5-inch stroke. We added a new oil pump and a Summit Racing oil pan, along with our SFI certified damper. For induction, we used the Edelbrock Performer RPM air gap dual plane intake manifold. Next, E3 Diamond Fire spark plugs and MSD ignition components. Finishing off the top end were a set of Summit Racing 1.7 ratio rockers and TrickFlow's 225 high port cylinder heads. These upgrades netted a stout 344 horsepower and 398 pound-feet of torque in the dyno cell. But the last upgrade was the most impressive. After dropping in a TrickFlow Specialties hydraulic roller cam, the Windsor made 448 horses and 423 pound-feet. A common question I always get asked, why do such a careful teardown when half the parts aren't going to be reused again? Arguably, teardown is as important as assembly. It gives an indication on how things are wearing, from the valve train to the bearings, and will also tell you if something is going to be goofy before you start. You can learn a lot just by looking at the distributor gear. If the oil pump is putting too much strain on it, the gear will wear excessively. The wear pattern on this gear is centered and the teeth aren't knife-edged or worn. So far, so good. The valve train will often reveal a poorly running engine. But after removing the valve covers from this Windsor, we made an unexpected discovery. You'll notice there are no push rods in this engine. Now, this engine was drug out of our archives, so obviously there was something else that needed push rods worse than this one. But that's okay, it'll actually save us a little time. With the rockers removed and carefully organized in the engine assembly tray, we'll gingerly pry off the intake manifold to examine the lifters. As these hydraulic roller lifters come out, the first thing you want to look for is any tracking or wear on the rollers themselves and any wear on the bodies, which would indicate an oiling problem or a geometry problem. These look spectacular. Also, you want to look for wear on the pushrod cup itself, and like I said before, you want to stick them in the order as they came out of the engine. With the cylinder head off, we can get a glimpse at the top of the piston. Even with as little runtime as this engine has, the carbon tracking on the top of the piston looks great, and the hone looks good. Most importantly, the top of the piston is dry, meaning it's sealing up. Also, there are no burn marks or discoloration between the cylinders, so the head gasket was sealing properly. A well-running engine. Next, we're going to drain the oil into a clean pan. That will give us a look to see if there's any debris in it, and we're also going to cut apart the filter. If the oil looks milky or diluted, it could mean there is a coolant leak somewhere internally. If the oil smells like gasoline, the engine is poorly tuned. Any metal chunks that come out would indicate some sort of internal failure, usually the bearings. With a Goodson oil filter cutting tool, we'll take apart the filter. It works just like a can opener. Oh, look at that. We'll thoroughly look through the pleats in the filter for any debris. It catches anything from flecks of paint and silicone to small metal shavings left over from the machining process. Large amounts of debris indicate a problem. There's no particles in the filter or in the oil itself, so that's a good indicator that the engine is fine. We still have to get the rest of the parts out, but chances are they're going to look great.
Up next, high octane and high horsepower.
We are continuing on our high compression 632 that we're doing for Jeremy and Eliza down in XLR. This is going to power their Wild Willys wagon. Now this bullet is going to make well into the 1,000 horsepower range, and they need that kind of power to motivate that thing through the mud. It started with a solid foundation from Blueprint Engines, using their 632 cubic inch Big Block Chevy short block. It's designed to run on pump gas and crank out over 800 horsepower. Since we're looking to add another decimal figure to that number, we made some changes. First, a set of Holley Elite Sportsman Series 42cc domed pistons took the compression ratio up to a stout 15.03 to 1. The pistons were paired with a set of Eagle forged H-beam connecting rods with an upgraded ARP L19 bolt. Comp Cam's solid roller camshaft will give the proper lift and duration for this high performance application. A Jesel belt drive is used for precise timing. An ATI super damper will keep the harmonics in check. On the bottom end, a Melling high volume oil pump and a 7-quart oil pan. Then we address the top end with AFR 385cc cylinder heads. They flow 452 CFM at 800 thousandths valve lift, and that extra air will help us reach our power goal. For the valve train, we chose Comp Cam solid roller lifters, heavy-duty trend push rods, and finished up with a rigid and accurate Jesel shaft rocker system. The induction was capped off with an Edelbrock Super Victor 2 intake manifold that's ready for a 4500 series Dominator carb. An MSD crank trigger assembly and matching distributor will light the air-fuel mix. A set of Summit Racing polished cast aluminum valve covers sealed up the heads. For spark plug wires, we went with a set of MSD 8.5 superconductor wires. Now, these are the same type they'll use on a top fuel car, so if they're good enough for that, they're good enough for us. They have a resistance level of less than 50 ohms per foot. The lower, the better. These come in either black or red, 90-degree boots, or multi-angle boots as well. They are cut to fit, and I've already gone ahead and made them up to fit the engine, so they fit tight and out of the way. We're using the right stuff from Permatex on our water pump gaskets. It'll create a watertight seal between the pump and the engine, and just as important, it will help keep the gasket in place during installation. This is very helpful if you're doing the job inside the tight confines of an engine bay. For efficient cooling, we're installing a Summit Racing billet aluminum electric water pump. It's rated at 60 gallons per minute. For high performance lubrication in this bullet, we're going to be using Royal Purple's XPR in 0W20. Race Gas Race Fuel Concentrate is the official fuel concentrate for us here at Engine Power, and we've used it on several of our big power applications. The next generation fuel concentrate is Race Gas Ultra. This is designed to take 93 octane pump gas all the way up to 112, which is 7 octane numbers higher than the original 105. And it's easy to use with no mixing cup. You simply take 32 ounces and mix it with 4 gallons of gasoline and shake vigorously. Just like the original, Race Gas Ultra raises not just the octane, but also the chemical oxygen and chemical energy of the fuel. It's designed specifically for boosted, nitrous, or high compression engines. Our 632 has a compression ratio of 15.03 to 1, making it the perfect candidate for this fuel concentrate. We're finally to my favorite part of all of this, the dynoing, and we're going to baseline this engine running it from 4,500 to 6,500 RPM at 600 RPM per second to make sure everything is okay. So all that's left is to fire it up. Hold on to something because first hit. All right, the initial hit looks good. We stopped the pull at 6,500, so we haven't reached peak power yet. It's making 975 horse at 6,500, but peak torque is up at 809 pound-feet at 5,700, which is a great baseline. That means everything is working and it still has its guts. And now the fun part comes, tuning.
Up next, we promised the crew from XOR a 1,000 horsepower engine, and they're here to hold us to our word.
That's fantastic. That is unbelievable.
Welcome back. We are continuing on the dyno session of our 632 that's going down to XOR. Now, before we do any sort of mechanical changes with it, we're going to change the operating range of the engine. It's designed to run between 5,000 and 7,500, so we're going to actually make our pulls in that range. And we're also going to knock down the acceleration rate from 600 RPM per second to 400 RPM per second because it's going to load the engine more like it's in the vehicle. Let's give it a shot. We set a goal of 1,000 horsepower for this engine, and on the first full pull, we're almost there. 981 horsepower at 7,500 RPM and 819 pound-feet of torque at 5,700 RPM. Searching for more power, we added 2 degrees of timing for 32. We picked up 6 horsepower. Torque dipped slightly to 817 pound-feet. Made a little bit of change. Got to keep going. After adding 4 more degrees of timing for a total of 36 degrees, we liked our odds for breaking 1,000 horsepower. Grand finale. See what it really makes. Look at that. 1,020 horse and 830 pound-feet of torque. That is that's a real race bullet right there. Awesome engine for bolt-together parts. That is spectacular, actually. Jeremy and Eliza can't wait to get this big block going in their Willys wagon. And when they heard it running, they ran down to the dyno cell.
Are you finished?
Not quite yet. Now this thing's making great power, but all it's left are for you two to make a pull on your own engine. So it's fair. I'm gonna pick who makes the first pull, right?
Oh.
But I'm gonna make fate decide. Heads, tails,
Tails.
right?
Did I say it was tails?
Tails make the first pull.
Yes, I get to pull it first.
All right, are you nervous?
Yes, I'm nervous.
I would be nervous too. That's what I'm about. There you go. There you go. Okay.
That's fantastic.
See?
That is unbelievable.
So you're doing a 1,000 horse engine. You just dynoed a 1,000 horse engine.
Holy cats.
Is that better than riding a roller coaster?
That is unbelievable.
Watch that. And away you go.
Oh my God!
So I didn't.
That is so scary. It's fun.
I didn't. See? You made the same as him. Nice and smooth. This thing is literally ready for you guys. So now you have to complete the vehicle. So.
Well, now we should go work on it.
Yeah.
All right.
Gotta see you later then.
So, here's we got one thing though.
Sure.
So once we get it all done and it's running, driving, you're gonna have to come down and drive it.
That is an absolute yes. Very much looking forward to that.
Yes.
Hey, nice job. You didn't.
Thank you. I don't know. Awkward. What do I do with my hands?
You got awkward. I don't know what to do with my hands. MATCO Tools 3/8-inch high-power impact wrench combines the power of corded tools with the convenience of cordless ones. With no brushes to wear out or replace, the motor provides dependable performance and a long service life. It delivers a max torque of 150 pound-feet with 3,100 impact blows per minute. The patented hammer mechanism reduces vibration for increased comfort during use, and it also has an integrated LED light that illuminates dark work areas. The 16-volt Infinium lithium-ion battery is compatible with a wide variety of other MATCO cordless tools. You can check it out along with a lot of other cool stuff at matcotools.com.
Up next, all the benefits of EFI, the straightforward setup of a CARB. This kid has got it all.
Welcome back. Our 632 is very healthy, cranking out 1,020 horsepower on the dyno. And we've got one more thing we're going to try to get even more power out of this engine. This is Holley's Sniper EFI Stealth 4500, the next generation of their Sniper EFI throttle body systems. This one contains 8 100-pound-per-hour injectors in it and will support up to 1,500 horsepower naturally aspirated and 1,250 horsepower in forced induction applications. It has 2 1/8-inch throttle blades and will flow up to 1,440 CFM. The ECU is mounted right to the throttle body itself and is capable of controlling the ignition, the fuel, and a whole lot more. It comes with everything you need to wire it up, and it's actually very easy with only 4 electrical connections. This is high-tech at its finest, with 6 programmable ground outputs and 5 programmable ground inputs, so it can control external devices, such as nitrous or boost control solenoids. It comes with a Bosch wideband oxygen sensor and install kit. It's all controlled via a 3.5-inch touchscreen. No laptop is required. It goes on identically to the 1,475 CFM Ultra Dominator that just came off. Even the fuel connections are in the same place. Install a coolant temp and O2 sensor, wire the main harness, and it's ready to rock. With everything installed, I've programmed the computer to have a 14.1 air-fuel ratio, and we're going to see if we can make the same power as our old Dominator did. With nothing else that's impressive, that is the first pull out of the box. And look at that, 1,022 at 7,400, 821 pound-feet at 5,700. Now that's a little bit more on horsepower, a little bit less on torque, but that is literally the first hit off a fresh injection system, just putting it on and making a pull. The advantage of EFI over a carburetor is pretty straightforward in this application. You don't have to take any jets or air bleeds around to make a tuning change. Plus, you don't have to get under the hood, and in this case, get covered in gasoline and mud. Now, as far as power is concerned, because of their CFM rating and the amount of fuel that goes through them, they'll make the same power. And because this EFI unit is very, very much mimicking what a carburetor does in the manifold, it's going to make the same power, maybe even more. So, all good. About $300 price difference, but totally worth it when we're doing what we're doing. For more information on anything you've seen on today's show, visit PowerNationTV.com. To have an engine make more power, a common technique is to increase its cubic inches, and you can do that 3 different ways. You can increase the bore size, the length of the stroke, or a combination of the 2. You've heard the term stroker when talking about high-performance engines, so that's what we're going to go over today. But what exactly does stroker mean? Simply put, it's an engine that has the stroke of its crankshaft increased beyond its stock specification. This mod can be done 2 different ways. First, you can offset grind the crankshaft. Before aftermarket crankshafts were readily available, the crankshaft's rod journal would be intentionally ground to a smaller diameter and to a center line further from the actual center of the crankshaft. This effectively lengthened the travel of the piston in the cylinder, increasing its cubic inches. But the offset grind yielded a small increase because the crankshaft can only be ground so much. In addition, it was labor-intensive, expensive, and potentially weakened the stock crankshaft. The second method is to replace the stock component with a purpose-built aftermarket crankshaft. These are designed specifically for longer strokes, are constructed out of better material, and are built to yield maximum cubic inches without sacrificing strength. We build stroker engines here all the time, and they fall into 3 categories. Over square, meaning the bore is larger than the stroke, square, meaning the bore and stroke are equal, and under square, meaning the bore is smaller than the stroke. Over square strokers are common in most racing applications. The larger bore and shorter stroke produce the needed air displacement while keeping the average piston speed lower at high RPM, which improves reliability and allows efficient air induction. Square strokers have a good balance of horsepower and torque production. They can be tailored to make stout low-end torque or high-end horsepower depending on the components selected. They are excellent for weekend warrior race cars and just about any high-performance street car. Under square strokers really shine in lower RPM, high torque applications. When the engine's bore size is limited, an aftermarket crankshaft will increase the size by 50 or 60 cubic inches. For instance, a 351 Windsor with a 4030 overbore and a stock stroke of 3,500 equals 357.15 inches. Increasing just the stroke to 4,170 gives us 68.36 additional cubes. The result is a 425.53 cubic inch engine. Several aftermarket companies offer not only stroker crankshafts, but entire rotating assemblies with all the associated parts to get your bullet together. The only thing that limits stroker applications are the physical size of the engine block and your bank account.